Hello, hi everyone. Welcome to the Student Debate. This is your Swasa. Today we are going to discuss about electric current. In the previous video, if you observe, I explained entire concept. So right from starting to ending. So each and every point I explain. Now we will do practice. Okay. So like how they will ask questions, what type of questions they will ask. So this we will discuss electric current because few days onwards I'm continuously explaining the concepts. So practice session we need to discuss today. Stay right right with okay. So we'll start with a few questions, then we'll go to the problems. Okay. So problems are there right from starting with a few questions. Few questions we'll discuss. After that we'll go to the problems. Okay. So be ready. What is an ammeter? How is it connected in a circuit? Ammeter is a device. So ammeter you can observe. So this ammeter. Ammeter is a device. Electric current. Positive terminal. Electric current. Electric current. Electric current. Electric current. Okay. So this is the electric current topic. This is the electric current. So anyway, CBSE Grade-10 physics. Right. What is an ammeter? What is an ammeter? What is an ammeter? How is it connected in a circuit? Ammeter is a device which is used to measure the electric current in the circuit. So it will be connected in series combination. So ammeter will be connected in series combination. Right? Okay, done. Now, what is meant by potential difference between 2 points? Potential difference between 2 points is nothing but the work done to bring unit positive charge from one point to another point within the conductor is called potential difference. So what is SI unit of potential difference? SI unit of potential difference is SI unit of potential difference is volt. So name the device which is used to measure electrical potential difference and state how it is connected in an electric circuit. So voltmeter is a device which is used to measure the electric potential difference. Voltmeter is a device which is used to measure the potential difference. Voltmeter will be connected in parallel combination. Okay. Name and define SI unit of resistance. Name and define SI unit of resistance. Name and define SI unit of resistance. So V equal to IR. Yes or no? V equal to IR we can take. Or I equal to Q by T. So we can take like this, V equal to IR, R equal to V by. So 1 ohm is defined as potential difference 1 volt and current 1 ampere. 1 ampere. 1 ohm is just defined as 1 volt of potential difference applied across the ends of the given metallic conductor. 1 ampere of current is flowing. R equal to V by N. Now, define resistivity of a material, give its SI unit. Define resistivity of a material, give its SI unit. Very, very important. So, SI unit of resistivity. SI unit of resistivity we'll discuss now. SI unit of resistivity. SI unit of resistivity. Normally V equal to IR, right? So, sorry. We can take so we can consider R equal to rho into L by A, rho equal to RA by L. Yes. So resistivity is equal to resistance of the material per unit length, R by L into A, resistance of the material per unit length and unit cross section area. So SI unit of resistivity is ohm meter square by meter. Meter get cancelled. So SI unit of resistivity is ohm meter. SI unit of resistivity is ohm meter. Very nice. So that's enough. Define a resistivity of material, give its SI unit. Resistivity is equal to resistance of the material per unit length and unit cross section area. So SI unit of resistivity is ohm meter, right? Yes. Now, few more concerns. List the factors on which the resistance of a conductor depends. Write the formula showing the relation between these factors. Okay, R is directly proportional to length of the conductor. R is inversely proportional to area of the cross section. R is directly proportional to length of the conductor. R is directly proportional to length of the conductor. R is inversely proportional to area of the cross section. R is directly proportional to L by A. R equal to rho into L by A. Okay. So this is about resistance is directly proportional to length of the conductor. Resistance is inversely proportional to area of the cross section. So R equal to directly proportional to L by A. R equal to rho into L by A. Okay, so this is about resistance. Resistance depends on length of the conductor, area of the cross section, and temperature and material. Temperature and material. Okay, so these are the factors. These are the factors. Okay, so these are the factors. Now, so what are the write the factors on which resistivity of Y depends? Write the factors on which resistivity of Y depends. Resistivity, okay, so on resistivity, so resistivity I'm taking on it. So we can take temperature. So temperature and material, nature of the material. So temperature and nature of the material. Temperature, first one, and second one is material, nature of the material. Okay, so these are the factors. These are the factors, right? Now, now, so I'll go to the remaining questions. So the charge possessed by an electron is 1.6 into 10 power minus 19 coulomb. Find the number of electrons that will flow per second to constitute a current of 1 ampere. Okay, so this is very, very important. I'll write the question, just check once. The charge possessed, question is the charge possessed. The charge possessed by an electron by electron is 1.6 into 10 power minus 19 coulomb. Okay, find the number of electrons. Find the number of electrons. Number of electrons that will flow per second. Okay, to constitute a current of 1 ampere. A current of 1 ampere. Okay, so this is the question. This is the question. Just check once here. The charge possessed by an electron is 1.6 into 10 power minus 19 coulomb. So this is nothing but electron. So E is given 1.6 into 10 power minus 19 coulomb. Find the number of electrons on charge. On electron, how much charge? So find the electrons that will flow. So electrons in the sense we have to find out n. That will flow per second. So time is given 1 second. 1 second. So to constitute a current of 1 ampere. So I equal to 1 ampere. Now we can take the formula. The formula is I equal to Q by T. I equal to Q by T. Q equal to NE by T. Now I equal to NE by T. Okay, so by given data we can write I equal to 1 ampere, time equal to 1 second, and E equal to 1.6 into 10 power minus 19 coulomb. So we need to find out n. So from this n equal to I into T by E. Now n equal to I into T by E. Now I equal to how much 1? T equal to how much 1? Electron. So 1.6 into 10 power minus 19 coulomb. So 1 by 1.6 into 10 power 19. If you do this, so n you will get 6.25 into 10 power 18 electrons. 10 power 18 electrons. Okay, so this is the answer. 6.25 into 10 power 18 electrons. So this is the answer. Just check once if you have any doubts. 6.25 into 10 power 18. 10 power 18 electrons. Right? So I hope it is very clear to you all. Understood? So once again check here. The charge possessed by an electron is 1.6 into 10 power minus 19 coulomb. Find the number of electrons that will flow for second to constitute a current of 1 ampere. Okay. Now, here on electron how much charge is given and time is given. And one more thing, electrons we have to find out, current is given. So we can find out I equal to Q by T, NE by T, I equal to NE by T, N equal to I into T by E. So this is the given data. Substitute the data, I'll get the answer. Okay. So I hope it is very clear. So if you have any doubts, you can ask. Next question. So I'll explain next question. Check once. Right. Now, one more question. So this is very, very important, but I'll explain. Very, very important question. If you know the answer, you can try it. A current question. A current of 500 milliampere flows in a series circuit containing an electric lamp, okay, and a conductor and a conductor of 10 ohm when connected to 6 volts battery, find the resistance of the conductor, find the resistance of the electric lamp. Find the resistance of electric lamp. So this is CBSE. So this question, CBSE 2020 question. Okay, so read the question once. Before solving any problem, you must read the question first. Okay, a electric current of 500 milliampere. So milliampere is given. So here current is given, 500 milliampere. Current flows in a series containing an electric lamp and a conductor of how much? Electric lamp and a conductor. Just check once. Here, a conductor of 10 ohm resistance when connected to 6 volts battery. So, potential difference is given. Find the resistance of an electric lamp. Resistance of the electric lamp. So, we have to find out. Okay, so we have to find out. I hope it is very clear. First, write the given data. So, given data you have to write. What's the given data? First one. So, current is given. Current is how much? 500 milliampere. First one. And second one is an electric lamp. So, this is RL you can take. This is the RC conductor. So, conductor resistance is given RC, that is 10 ohm. When connected to 6 volts battery, so 6 volts battery, find the resistance of the electric lamp. So they given in the question. Find the resistance of the electric lamp. So RL we have to find out. Check whether all are there in one units or not. All are there in one system or not. So SI system. SI system or not. You have to check once. Okay. So check once here. Now you can observe milliampere is given. Normally milliampere is nothing but 10 power minus 3 ampere. Microampere is nothing but 10 power minus 6. Okay. Now I equal to VR. Formula we have to take. R equal to I by V. So here R, there are two resistance, RL and RC. RC is the conductor, RL is electric lamp. So RC plus RL. First one RL, next RC. So write in that way, it's fine. However you write it, same only. So RL plus RC equal to current. I equal to how much? 500 into V equal to IR. R equal to I by V. Correct only. Sorry, V equal to IR, right? Ohm's law. V equal to IR. V equal to IR. R equal to V by I. Now R equal to V by I. So V is how much? 6. I is how much? 500. 500 into 10 power minus 3. So it goes up 6000 by 500. So 2020 get cancelled. R C how much? 10. RL plus 10 equal to 60 by 5. So 12 we can go. So 12. So then RL equal to 12 minus 10. Then RL equal to 2 ohm. Is it clear? Is it correct? Is it correct? Let me know. If it is wrong, just let me know. Is it correct or not? Done. So next. So check once again I will explain. A current of 500 milliampere flows in a series circuit containing an electric lamp and a conductor of 10 ohm. When connected to 6 volts battery, find the resistance of resistance of the electric lamp. Okay, yes, 2 ohm only. Here current is given 500 milliampere. RC is given, so 10 ohms. Potential difference is given. RL we have to find out. V equal to IR. R equal to V by I. So here RL plus RC equal to 6 by 500 into 10 power minus 3. So here 6 and so 6. We can take it like this. This 10 power minus 3 goes up. So positive value will be there. So 6000 by 500. So 200 0 get cancelled. 2 zeros will get cancelled. 5 12 60 and RL plus 10 equal to 12. RL equal to 12. 12 minus 10. So then we'll get 2 ohm. I hope it is very clear to all. Right? So then we'll go to the next one. I'll explain next problem. Just check once. Be ready. So tomorrow onwards, demo classes are going to start at 9 p.m. So everybody join. So one subject will start. One subject. Those who want to join to the class, you can join and listen to the class. If you like it, you can get explanation from them, right? So you can get the classes also. So simple question, easy question only. So this will do it. How much energy is given to each coulomb of charge passing through 6 volts battery? So this is very simple question. Sir, you are seeing all simple questions. Yes, simple questions only, but easy questions only. They may ask, right? They will ask in the exam also, right? These questions they will ask, right? So we need to explain. How much energy? How much? How much energy is? How much energy is given? How much energy is given to each coulomb? Each coulomb of charge. Each coulomb of charge passing passing through 6 volts battery, passing through a 6 volts battery. So this is the question here. How much energy is given? How much energy is given? How much energy is given to each coulomb of charge passing through 6 volts battery? Okay. So each coulomb Q equal to 1C and potential difference is 6 volts. Energy is nothing but W. So we need to find out W work. Yes, 6 joule is correct. So V equal to W by Q. W equal to V into Q. So W equal to V how much? 6. Charge how much? So 6 joules. So this is the answer. Very simple, very easy. You need to understand what exactly they asked in the question. So if you identify what is the exactly question, so by writing the formula, substitute the values, you can get the answer. And at the end, units you have to mention. So very, very important. You have to mention the units. That's enough. Very simple, right? Now one more question. What is the resistance of an ideal voltmeter? Resistance of an ideal voltmeter. Voltmeter resistance. How much? Anyone can say voltmeter. Ideal. So ideal voltmeter resistance. Ideal voltmeter resistance. No, ideal voltmeter resistance is infinity. Ideal ammeter is 0 ampere. 0 resistance. 0. Ideal voltmeter is infinity. Ideal ammeter resistance is 0. Actually, it is a part of teaching. Crazy ideas, crazy thoughts. So, a 6 ohm resistance wire is doubled on itself. Calculate the new resistance of the wire. Anyone can do this? So, I am giving one question. A 6 ohm resistance wire is doubled on itself. Calculate the new resistance of the wire. So, find out new resistance. Try to identify. Okay. So, one more question. One more question I am giving. Just to try this one. How much work? So, question number. How much work is? How much work is done? How much work is done in moving a charge of 2 coulomb from a point of 118 volts to a point at 120 volts. So can you do this one? This question. 24, eh? Will you get 24 by solving this one? We'll see now. How much work is done in moving a charge? So Q is given and potential difference is given. So V equal to W by Q, right? So W equal to V into Q. So this we have to do it. Given values Q equal to 2C, and here V1 equal to 118 volts, V2 equal to Ajit, enter. Very good. Okay, V2 we have to find out. V2. V2 is how much? 128. 128. So V2 minus V1 equal to 128 minus 118. So how much you'll get? 10, right? 10 volts. V is 10 volts. Yes or no? V is 10 volts. Now we can find out W equal to V how much? 10 into 2. 20, right? Someone is saying 24. 20 you will get answer. So W equal to 20 joules. They're asking how much work is done. How much work is done to moving a charge of 2C, right? So this much work. Do you have any doubt? Let me know. If you have any doubts, you can ask me. Is it clear? Yes. Thank you. So that's enough. This is the answer. Now we'll go to one more question. One more question we'll discuss. So we'll go to one more. Draw the VI graph for ohmic conductors and non-ohmic conductors. Draw the graph for ohmic conductors and non-ohmic conductors. For ohmic conductors, so if you draw the graph, so V on y-axis, I on x-axis. So this is the graph for ohmic conductors. Ohmic conductors. Coming to non-ohmic conductors. Non-ohmic conductors. So this is non-ohmic conductors. V on y-axis. So I on x-axis. The graph is curved like this. Okay. So this is for non-ohmic conductors. Non-ohmic conductors. Non-ohmic conductors. Non-ohmic conductors. How can three resistors of resistance 2 ohm, 3 ohm, 6 ohm connected to give a total resistance of. So this question also very important. So combination. So they will give resistors, few resistors they will give. They will ask to draw or connect or give the combination or show the circuit diagram in order to get the resultant. Okay, in order to get the value what I am expecting like this. So they will give how can three resistors of resistance 2 ohm, 3 ohm and 6 ohm be connected to give a total resistance or to give a resistance of, so they given 2, 3, 6. Okay. First one is 2 ohm, 3 ohm and 6 ohm. Okay. So three resistance given. These are the three resistance. Once again I will draw clearly. I will write. So once again, so 2 ohm, 3 ohm and 6 ohm. Okay, so three resistors are given. So in order to get the value, so the value is 4 ohm and 1 ohm. 4 ohm and 1 ohm. We have to get how to connect. We have to connect these three resistors. So in order to get these values. So like we know the series combination, parallel combination, right? Series combination, parallel combination. So like that, how to connect these resistors. Okay. So in order to get this value, how? Check once. Okay. So I hope it is very clear now. I hope it is very clear. Now check once. Okay. So you can connect these two or in parallel like this and one value in series like one resistor. So 3 ohm, 6 ohm and 2 ohm. First, so you do this one 1 by 3 plus 1 by 6. So 1 by Rp equal to 1 by 3 plus 1 by 6. Then you will get 6, 2 plus 1, 3 by 6. So Rp equal to 6 by 3, that is a 2 ohm. So Rp equal to 2 ohm. So the final value is, so you can get here, here is 2 ohm, here also 2 ohm. So 2 plus 2 is 4 ohm. Understood? So you'll get 4 ohm. Clear? That's the answer. So first one you got it. You got the first one. First one you got. Next the second one. How to get? So connect all these three resistors in parallel combination. Connect 2, 3, 6 are in parallel combination. So 2, 3, 6. 2, 3, 6. 1 by, so 1 by Rp equal to 1 by 2 plus 1 by 3 plus 1 by 6. Then 6, 3, 3, 2, 1. 5, 6, 6 by 6. Rp. 6 by 6 is Rp value 6 by 6. That is one value. Rp is 1. 1 ohm. So you got the next value also. So like this we have to connect. I hope it is very clear. So first you have to take okay, check once. So 1 by 3 plus 1 by 6, 1 by 6, 2 plus 3, 2 plus, correct only 3 by 6, 6 by 3, 2, RP equal to 2. So 2 plus 2, 4, 2, 3, 6. 1 by 2 plus 1 by 3 plus 1 by 6, 3, 2, 1, 6, 6 by 6. You will get the answer. Okay, so I hope it is very clear. So this is the answer. Done. Now we'll go to the next one. So reverse, but RP equal to 6 by 6. We'll get the one answer. Circuit problems, we have to do it. So I'll give one question. So because it's very, very important question. So I'll draw the circuit diagram, try to do it. Question. Electric current. Very, very important. Electric current. Positive terminal, negative terminal, current is flowing. This is the circuit. Is it visible? Okay. Done. Now, so this is 6 ohm and 12 ohm. So dot. This is a 12 ohm resistor. Sorry, potential difference. This is 8 ohm. Now, can you find out? First point is current through 8 ohm resistor. So I8 means I8 ohm resistance. Second one, potential difference. First one, second one, potential difference. Potential difference across 12 ohm and 6 ohm. So across here we have to find out potential difference. And the next one, current through 6 ohm resistor. First you find out these two, then we'll go to the next one. So try to solve it and let me know the answer. Who will? Once again, current through 8 ohm resistors, potential difference across 12 and 6. Later, we'll find out. So current through 6 ohm resistor. Third one is current through 6 ohm resistors. Okay, chalo, start do it. Once try to find out. Okay, so here you can see. So current through 8 ohm resistor. So 8 ohm resistor is connected in series combination. To the circuit you have to check. to the cell or battery to check how it is connected. Series. So if it is series combination, so whatever the current is flowing in the circuit, so the same current will flow through 8 ohm resistor. So that's why you can find current in the entire circuit. First to find out current in the entire circuit. So that's enough. First one is, so we know this resistance how much you'll get. So 1 by 12 plus 1 by 6. So 1 by Rp equal to 1 by R equal to. So 6 plus 1 by 2, 3 by 12. So 1 by Rp, that is Rp equal to R equal to 12 by 3. That is equal to 4. Okay. So here the total resistance is 4 ohm. Total resistance is 4 ohm in parallel combination. First point. Coming to the second point. So 8 plus 4. So 12 total resistance. R equal to 8 plus 4. Total is 12 ohm. That is overall R. And V we got 12 volt. Okay, 12 volts. Now V equal to IR. I equal to V by R. So 12 by 12, that is I equal to 1 ampere. So first one is, we got the answer. So as I said, 8 ohm resistor is connected in the series circuit. Okay, so connected series to the battery, a cell or battery. So here a cell given, so that's why to the cell it is series. So whatever the current is flowing through entire circuit, same current will flow through 8 ohm resistor. So that you have to remember. So carefully you have to observe that point. So answer is 1 amp, current is 1 ampere. And second point is potential difference across this one. So we know total current, I we know I equal to 1 ampere is flowing. So if you take it, this is the overall resistance. Overall resistance is 4 ohm. So if you take it as a resistor, so current is flowing. So anyway it is series. So current is flowing 1 ampere. So overall resistance is R. We have to find out potential difference across these three. So V equal to IR. IR is nothing but 1 into 4. So that is nothing but 4 volts. So V equal to 4 volts means across this 6 ohm and 12 ohm, the potential difference is 4 volts. Now we have to find out current through 6 ohm resistor. So R is given, third point, R is given 6 ohm and BV got 4 volts. Now we have to find out the current. Current we have to find out. So V equal to IR. Because potential difference here and here same only, potential difference we know, resistance we know, we can find out the current. V equal to I equal to V by R. So potential difference how much? 4. Current is resistance how much? 6. So 2 by 3. That is the answer. Is it clear? So if you have any doubts, you can let me know. You can ask, is it correct or not also? Just let me know. Is it correct? Whatever I did. So 2 by 3 ampere. And here because it is in a parallel combination, actually 1 ampere is flowing, right? 1 ampere is flowing. So whether whatever you did it is correct or not, so we need to identify. So we have to check. How can you check? How can you check? So here 1 ampere of current is flowing through this parallel combination. So current must be divided. So through this one and through this one. So here 0 point is something it is coming, right? 0 point, so 18, 0.66 like this. Oh, actually for grade 10, these are the problems very important. Okay. In exam point of view, I'm doing. It's not about it is easy or difficulty. So it's not about easy or difficult. So it is about exam point of view. Okay, so let me know, is it clear or not? That's enough. Okay, definitely I will solve big problems, lengthy problems also. We'll do it. No worries. Actually, these are all questions only. Only questions. Okay, you can check this one. All questions only. There is no answers. Just we are doing. Okay, we'll do big problems also. Fine, no problem. Wow, what a great idea. Okay, done. So that's enough for today. Do more problems or we'll do practice classes. So if you like the channel, if you like the content, if you like the explanation, so please do like, share, and subscribe to Student in the Brand. This is our sir from Student in the Brand. And tomorrow onwards, the demo classes are going to start. Tomorrow onwards, Monday onwards, I already posted the schedule. So for not only 10th class, remaining class also soon we will start demo classes for expected faculties. So most expert faculty members like 15 years, 10 years, 20 years, even 30 years experience faculty members are available. Okay, so they are ready to teach you. They wanted to teach you. They are very passionate to teach you. So come and join to the demo classes. So involve in the and participate in the festival of demo classes, right? So tomorrow onwards, 9 p.m. we are starting right from tomorrow. Okay, so a schedule also I posted. Just check once and join to the schedule and join to the live classes. Zoom ID, everything, all credentials I given. Just go and check in community post. So thank you so much for joining, attending, and listening my class. Thank you so much. So thank you so much. We'll see you in the class, in demo class.